All right, welcome to Chapter 4, Section 3, called Functions. This is for Math 8. So just a couple of things on the front screen here. You'll see a due date on your screen. I don't see it on the teacher preview, but you'll see it on your screen as a student. For attempts, you can see that we always have unlimited attempts, so I'm on one of unlimited attempts here. This particular assignment has 10 questions on it, which should be the maximum. I know one of the sections ended up with 13 on accident, but 10 should be the maximum. Grading policy is best score, which just means whichever attempt is the best one is the one you get to keep, and partial credit is enabled. So if you answer 1 of 10 questions, you get to keep the points for that one question. Let's see, down here it says, please remember once you start your homework, you must finish your homework before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, you will see a submit assignment button. And whenever we want to leave the screen, it doesn't matter if we finished or if we've even started. Once we click that start button to leave this screen, we want to click that submit assignment button. I know it's not here. It'll be on your screen as a student. That button does 2 things. Number 1, like that previous screen said, it'll stop the system from locking you out of all of your other assignments. So that's definitely important. It doesn't restart you on the homework or anything. It saves your place. So if you've already answered some of these and you've gotten them correct, you'll still start back with those correct again on the next attempt. And the other thing it does is it makes an effect in the grade book. So we can actually see as teachers what you've been doing. So definitely get a good habit of clicking that button. On this side here, we have 3 tools. There's explanation, example, and message center. Explanation will literally give you the solution to this problem type, or not the problem type, sorry, this exact problem. So it says you're going to lose your question attempt because it's not going to give you the answer and then come and let you type it in. Example will give you an example of this problem type, so it'll show you exactly what to do. Here's a function, and we've been working on functions for it's either been a couple of weeks now, or this actually might be the first week for Math 8 that we're jumping into functions. It's just another way of writing our equations. And we have a table. We've been definitely working with tables here for a little bit. And as we go down, we can see we're filling in the table with the given information and then completing the table here. So once we're happy with the explanation, we understand what we want to do, we can close it. We can also go back and look at another example if we want to. And then we can also use the message center to send a message directly to our teacher. So, hey, they know exactly where to, come help me or come help you. I said me, but I'm pretending to be the student here. All right, so we have this function here. It says the function h is defined by the following rule. So 2 things, because I think this might actually be the first time we've heard the word function in Math 8. So function, putting my letters backwards there. A function is, it's just a regular equation like we've been used to seeing it, but we see this function notation now, which is this h with the x in parentheses. And we read this as h of x, so that's how you read this, whatever the first letter is of x, which is in the parentheses. And this just takes the place of y. It lets us know right away it's a function, and we even call it a rule. So it has kind of some special rules to it once we start doing functions, as opposed to just being a relation, which we were dealing with before. So y is being taken over by h of x, but we can still use y if we want to just kind of simplify it. That's fine, but in the table we have x and h of x instead of y, so that's all we're doing there. So what we're going to do is we're going to take this equation, and I'm going to leave some of these open here. So here's the equation with the x's left open, and I'm going to leave them open because what I want to do is I want to go through and actually plug in the numbers that they're giving me for each one of these. So I'm going to make 5 of them real quick because that's how many problems they've given me. Well, not how many problems, I'm saying that funny. How many x's to test out for this one. And what we're doing for each one of these, and it'll make a little more sense I think when I fill this in, is we're kind of asking a question. If x is -4, so instead of it being x, it's -4, what is h of x or y? What does the equation equal if I input -4 into the equation? And this is kind of like a little machine, and I know I've seen it on some of the other ones where we have like this little funky machine here, and then we have input calculate, I put a T there, but being a little lazy, and then we have the output. So it's kind of like this little machine that you're putting a number into. So we're going to put the 4 in, we're going to calculate, and we're going to see what do we get out. So we can think of a function machine as it's like a little machine that it's giving us some answers. So 3 times -4 is -12 plus 4. So -12 plus 4, they're opposites, or one's negative, one's positive. So we're going to subtract, and 8 has is going to be negative because there's more negative than positive. 12 is the number 12 is bigger than the number 4, and it's a negative number. So when x is -4, 8 is, or y, or h of x is -8. Oof, I'm having trouble talking on this video. All right, the next one is -2. So we have 3 times -2, we get -6, plus 4. Again, they're opposites, we're going to subtract, and we have more negative than positive. The next number we have here is 1. So 3 times 1 is 3, plus 4. So this one, usually students don't get too tripped up on this one because it's 3 plus 4, so they just know, okay, well, it's 2 positives, I'm going to add them together. And then 3 and 3. So 3 times 3 is 9, plus 3 more, again, just 2 positives added together, so 12. And then the last guy here. So we have 3 times 5 plus 3, and then that's 18. So remember your PEMDAS rules on this too, because I have to do the multiplication before I can add the 4. We can't add 4 and then multiply by 3. It has to be multiplication and then addition. So just be careful about that as you type these guys in. Let's see, -2, and make sure that you are paying attention as you add them in. So this is what they want us to do to fill this out. So in the example, they had all of this work in a table too, and I know I created a table when I did this on the notes page, or something along those lines when we did it on the notes page. So that's something that you would have to create on your own. That's not something that Alex creates for you. Uh-oh. What did I do? Let's see. 3 times... Oh, why did I write plus 4? I'm losing my crazy mind here. I changed it to 3's on the last one and didn't even notice. The pattern changed. So this should have been plus 4, so this should be 13. Plus 4, so this should be 19. Oh, that was silly. I don't even know what I was doing there. So 13 and 19. There. Okay. Now my keyboard's not reacting the way... Oh, goodness. There we go. So, and that's actually another little nice thing about the program is it didn't immediately say, nope, you're wrong. It said, oh, part of your answer's wrong. Go back and try again. So it gave me another chance before just marking me wrong. I do like that about the program, that it gives you multiple chances. All right, so if we're thinking about these as a rule, and so the last one, we had 3 times the number, whatever number we plugged in there, we plugged in a bunch of different numbers, and then we added 4. So this was our rule. This is what we had to do to x, the input, every time to get our output, which was f of x, right? Or h of x in that one. So this was our rule right here. So when they're asking you to create your own rule on this one, it says below is the table of values of a function. Write the output when the input is n. So what we want to do is we want to think about what's happening here to all of these numbers. How do I go from the input to the output? And our question is, what will this be? So here's my input, is this column, and then down here, this is my output. So if I put a 5 in the machine, I get a 10. If I put an 8 in, I get a 16. The 9, I get an 8, or 18, not 8. So what we want to do is we just want to take a quick look and say, okay, well, how do I get from my input to my output? And for this one, if I do 5 plus 5, I'd get 10. So that would work. But if I add 5 to 8, that doesn't work. So I need to go back and try another option. 5 times 2. Let's try multiplication. 5 times 2 gets me 10. 8 times 2 gets me 16. 9 times 2 gets me 18. Ooh, that function rule does work. So I want to multiply by 2 each time. That's my rule. Whatever my input is, I'm going to multiply by 2, and that gives me my output. So even if it's n, and n just means it could be any number, we just don't know what it is. That's the same thing as saying it's x. So whatever number we put in here, what do we have to do to it? We have to multiply by 2. So it's going to be n times, and they're actually using a little times button here, 2, like this. So we're going to click here and go n times 2, which I would also just write as 2n. You know, if I was simplifying that, but since they have a little times button, I'll go ahead and use it the way they want me to. All right, we're going to do one more of these guys. I'll switch the colors so we can see their different problems. 1, 2, 3, 4, and n, negative 10, negative 12, negative 14, negative 16, and then we're coming up with a rule here. Okay, so we did multiplication on the last one, but remember, it's not just multiplication. We can do addition, subtraction, multiplication, or division. We just have to figure out what am I doing to get from here to here each time. I'm just trying to figure that out, that little piece. So let's see, if I want to go from 1 to negative 10, I could multiply by negative 10, but that doesn't work on this next one. If I do 2 times negative 10, I wouldn't get negative 12, I'd get negative 20. So multiplication doesn't seem to work. But I could subtract 11. 10 minus 11 gives me negative 10. 2 minus 11 does not give me negative 12. So 2 minus negative 11 will give me negative 9. So that doesn't work. Let's see, we can't really add anything. So I think what we're going to need to do, and this one, if I click on this too, I bet you what this is going to be more than one step. It's not going to just be addition or subtraction if we're looking at this guy. Let's see. So they're still just looking. 4 times. Okay, so they are looking at multiple steps here. So 4 times the input and then minus 6 if we look at this one. So they are going to be expecting us to find a multi-step one. They just don't really have that necessarily in the title here. And you wouldn't necessarily know that until you tried it out and you said, well, I can't do just multiplication or subtraction or addition or division. I'm going to have to do more than one thing here. So what they're doing is they're going through and first they're finding the difference of each one of these. So if I go like this, so, and we've been calling this the change in class, the change or the slope even. We're definitely starting to get more into slope now. I know I've been calling it the starting point and the change in class quite a bit. So with this one, we're going plus 1, plus 1, plus 1. With this guy, we're going minus 2, minus 2, minus 2. So we're going down by 2 each time. So we have a slope instead of 4, because slope is rise over run. We want to remember that part because that's how we're going to write our slope forever. That's pretty much the relationship we want to remember. And rise has to do with the output or the y, and run has to do with the x's or the input. So we have a negative 2. So this is a multiplication that we're going to be doing, as you can see here. So they say, okay, well, we're multiplying our input by 4 because they had a change of 4. So we're going to have this guy times negative 2, but we also have to do something else because that strictly doesn't work. If I just go times negative 2, well, 1 times negative 2 gets me negative 2. But now I need to get to 10. So I'd need 8 more to do that. Let's see if that continues to work. If I take 2 and I multiply by negative 2, I get negative 4. And if I subtract 8 from it, so this got me negative 10, which is what I wanted. This gets me negative 12. So we can kind of simply continue that rule by, once we figure out what we're multiplying by, now we can, that should be a 3. We can keep going on this one. So this will get me -6. If I subtract 8, that would get me -14. So this does seem to work, this rule. Once I multiply by -2, then I just subtract 8. If you notice, that's the same each time here, -16. So this subtract by 8 is the same. So I'm going to multiply by -2, like this, and then I'm going to subtract 8 from that. Okay? So this is just a multi-step problem where we have to find the change first. What am I changing by? What am I actually multiplying by? And then we can write the rule here. So I'm going to switch this around and go -2 times n, and then we'll subtract 8 from whatever we get there, and that'll land us on our output. All right. So let's go ahead and take a look at this word problem here. We have Latoya earns $53 each week working part-time at a bookstore. She earns one additional dollar for each book that she sells. Let A be the amount in dollars that Latoya earns if in a week if she sells B books. Write an equation relating A to B, then use this equation to find the amount of money Latoya earns if she sells 35 books. So we have a couple of tasks. Our first task is to write an equation relating A to B using this information up here. So that's our first task. Then, once we've written the equation, our second task is to find out how much money she'll earn if she sells a certain number of books. So let's think about the problem. And I know when I'm doing this in class, we have a starting point and we have a change. And the more we move forward here, I'm going to definitely relate these. Starting point is the y-intercept, y-intercept, and the change is the slope. And I know when I'm doing this in class, these words are either bolded together or we write them both down in the fill in the blanks. We definitely connect these two. But in a word problem, it's not going to tell you y-intercept and slope. It's not going to use those words in your word problem. But if you think of where am I starting and how am I changing that amount, am I going up by a certain amount, am I going down by a certain amount, what's my change, those are a little easier to wrap your head around when we're looking at a word problem. So that's why I relate these two words together. But we definitely want to understand, especially once we start graphing here, that our y-intercept is our starting point. And then we change we create a line from that using the slope. And the slope is the change. How much am I going up or down? So with this one, she earns $53 a week working at the bookstore. So no matter what, she's going to get $53 a week. That's a very low amount. I think we've had conversations in math class about this. $53 a week is kind of crazy, but we'll go with it. It'd be more like $53 a day, maybe. That'd be a little bit better. And then we also know that she earns $1 for each book that she sells. So $1 per book, right? So we've written our starting point and we have our change. And when we're looking for the change, we're looking for per, each, every. We're looking for some word that tells us there's going to be a multiplication happening there, because that's the change that we're looking for. We're also told to use specific variables. So A is going to be the total amount that she makes. Instead of Y being the output, A is going to be the output. And that's going to equal her starting point, because she has to make this $53. That's part of her pay. She gets that no matter what. Plus, because it's a change, it's an additional dollar. So that's a +1. So it's plus $1. But we don't want to just do $1. We want to do per book. So per, and they told us to use capital B for book. So instead of per book, we're going to write times B, or just B there. I also don't even need the 1. You don't have to write 1B. It can just be B. So this is the rule. This is her equation relating A and B. So her total pay equals $53 plus B. And I don't have to multiply B, because since it's $1 for every book, however many books she sells is the amount of dollars that it will go up by. So that's why we don't have any multiplication happening in front of the B there. It's just if she sells 35 books, she gets an extra $35, right? So with this one, we know she sold 35 books, so we're going to add the 53 to that. And I'm going to stop with color coding here just for a minute because it gets a little bit time consuming. So we have 88. So she gets $88 for the week if she sells 35 books. Putting a lot of effort in for that $88. That's pretty cool. That's definitely not a lot of amount of money for 1 week's worth of work. So not sure how often she works. Maybe she only works an hour a day or something. All right. So now we have this account that says Chris is putting money into a savings account. He starts, and it actually used the word starts, with $450. So we know how much is in his account to start with. And then each week he adds $60. So that's a change. I know he's adding $60 each, oops, I don't know what I did with the A and the C there, each week. So each is my multiplication word. I know that's happening every single week. He's going to be adding another $60 to this. So then they go through and they tell me that to let S represent the total amount of money in his savings account. So S is my output, right? Instead of it being Y, it's going to be S. And let W represent the number of weeks. So instead of each week, I'm going to go times W. And we're going to write an equation relating S to W. So that's what we're kind of starting on already. That's our first task. And then once we write an equation, we can figure out how much money he'll have after 16 weeks. So remember, it's his starting point plus the change. So it's going to be $60 each week, or just times W. So we've written this equation just by breaking down some of the basic information for what we have. What is he starting with, and how is he changing that amount? Ooh, and I want to do capitals because that's what they told me to do. They would mark me wrong for capitals or lowercase to capitals, but they would give me some grief about it actually, because that's not what they told me to do. If you use the wrong variables, you will get that wrong. And it'll actually tell you to use the correct variables before it marks you wrong. So now they're asking me at 16 weeks. So I know W is 16, because remember that means week. So I'm going to do the multiplication here. And I'm going to see what is S, which is the total amount of money in the account. What is it after 16 weeks? So I still have my $450. That's what we started with, or what Chris started with here. And now we need to do 60 times 16. So we get 960. And you could do like 6 times 16 and then put the 0 on the end if that made it a little bit easier for you. You could also break it down and do 6 times 6 and 6 times 10 because that would give you 36 and 60. 36 plus 60 gives you 96. Add the 0 on the end, you get 960. So there's ways to do mental math here where you don't necessarily need the calculator, but that also requires us to have our kind of basic math skills there, or math facts memorized in order to do that too. So now we're just going to add these guys together. So we get 0, 11, 10, and 14. So just to confirm, I want to make sure I didn't add that funny. Yeah, so 1,410. So he'll have $1,410 after 16 weeks. So he's definitely starting off a pretty good savings account here. If he can add $60 each week, and after 16 weeks, which is not very much time, that's only about 4 months, he'll have $1,400 in there already. So definitely a pretty good savings account. All right, now we're gonna take a step back, and I think we've done this same type of problem before, where we're looking at independent, and dependent variables. So with these ones, and the way we relate these on a graph when we're doing this, independent is always the X variable, and dependent always the Y. And I say X variable and Y variable, but it's really the X axis and the y axis. And I'm being a little more picky on that one because when we're doing word problems, we don't always label them x and y. It's on the x-axis, the x coordinates, the y-axis, which is y coordinates. But sometimes we label them differently. Like even this one down here below, it's b and u instead of x and y. So we have to be careful about just going for x and y. But what we're looking for is if it's dependent, then it needs something from this guy. So it needs the independent variable. This is the output, and this is the input. And sometimes these can be a little bit difficult to separate out because you have to think about what it is they're actually asking you. Because sometimes we look at them in a little different way than what the problem is presenting them to us. So we need to make sure we're specifically looking at what they're asking. So the amount of a certain medication taken in the morning influences the amount of sleep that night. So which is the independent variable? So if we're talking about amount of sleep and the amount of medication taken, and it even said the amount of medication influences the sleep. So medication influences sleep. So this actually pushes us towards which one's dependent, which one needs the other. So sleep is going to need the medication. So that would mean that sleep is dependent upon taking the medication. And in this one, if the medication was taken in the morning and for whatever reason we didn't sleep that night, does that take away the fact that we took the medication in the morning? Or maybe it was just, weird, it didn't work that day. Something like that. So the amount of sleep isn't going to affect the fact that you took the medication. But not taking the medication could very well affect the sleep, right? That's what this problem is saying. If we don't take the medication in the morning, we're not going to sleep at night. So they have a direct effect on each other, going from medication to sleep, but not backwards, not sleep to medication. All right, a person's muscle mass changes with age. Muscle mass increases into young adulthood and decreases after. Which is the dependent variable in this relationship? Age or amount of muscle mass. So we're looking for the dependent variable this time. So which one depends on the other? So they're telling us that muscle mass changes with age. So in this case, age is definitely going to be independent of the muscle mass. Muscle mass depends upon what age you are. So the muscle mass is going to be very dependent upon your age. If you're, much younger, toddler to kind of kid, before a teenager, your muscle mass will probably be lower because of your age. If you're kind of getting in your teenage years to, probably through your early 20s and maybe even 30s, your muscle mass will be higher than it was, and then it's going to start to decrease again. So it's going to kind of do this little bell curve. It's going to go up and then back down again. And this is based on your age. It's going to go up for a while and it's going to go back down. But if by chance someone, let's say they're 20 years old and they're right here, and they're not up here with the muscle mass, maybe they have low muscle mass, does that change the fact that they're 20? No, maybe they just have lower muscle mass for some reason. We don't necessarily know why, but that doesn't change their age, having lower or higher muscle mass. Or maybe a young person had higher muscle mass, like at 13 or something. And I'm just throwing some numbers out here. I'm kind of guessing because they're not giving us any of this. But this is just the idea. It could be higher, it could be lower, but that doesn't change your age. It doesn't have a direct effect on your age. We're not going to say, oh, well, your muscle mass is this at this point, so that means you must be this age. No, your age is going to stay whatever your age is. But there is a direct relationship between muscle mass and age. So this one is the dependent variable. All right, a function uses the input u to compare the output b, which is the dependent variable for this function. So we kind of talked directly about input and output up here. So the input, what we change, that's going to be our independent variable. And what we output, what we get from the input, is going to be our dependent variable. So if we're looking for dependent, we're looking for output. So that would be B. Check. All right. It's kind of a lot of talking on that one. Sorry about that. I know sometimes that gets a little bit wordy when I'm talking. All right, so Pablo tutors history. For each hour that he tutors, he earns $40. His earnings E in dollars after tutoring for H hours is given by the following function. So they gave us the function. They're telling us. And we know what the 40 represents. The 40, he gets $40 every hour. For each hour that he tutors, he earns $40. So 40H, that's going to be $40 per hour. And then they ask us, how much does Pablo earn if he tutors for 3 hours? Okay, well, if he gets $40 per hour and he tutors for 3 hours, we're just going to multiply. 4 times 3 is 12, and then I'm going to add the 0 on the end. So that one was definitely a little quicker. We didn't have to break down the problem as much because they actually created the equation for us, or the function for us there. All right, let's see. Next one. Isabel receives $50.75 gift card for a photo center. She used it to buy 7 prints that cost 7 cents each. The remaining balance B in dollars on the card after buying X prints is given by the following function. So they broke this down again. They told us what these mean. Instead of just giving us an equation and saying plug in a number, $50.75, that's how much was on the gift card. 7 cents here, that's how much it costs her per photo. And X is the number of prints. So 7 cents per photo. And then it asks us what's the remaining balance after 40 prints. Well, if she started with $50.75, we need to subtract 7 cents per photo, which is $40. That's what they're asking us to do. So 50. So with this one, we want to do our multiplication. 7 times 4 would be 28. And then we're going to have to take into account all of these zeros. So if I did it that way, 7 times 4 would be 28, and I could put a 0 in the end because of this 0. But now I need to take into account these pieces. So we need to move the decimal back, actually. So that can get a little confusing when we have multiple decimals like this. But we can do 7 times 4, which is 28, add the 0. And now look at this and go 1, 2. So I'm going to go 1, 2. So I could do mental math on this one. It just requires us to remember kind of how to move the decimal there. But 7 times 4 is definitely easier than 7 cents times 40. It tends to make a lot more sense in our heads to just go 7 times 4, oh, that's 28. I can add the 0 back on from the 40, and now I can move my decimal over. So she used $2.80, and we're going to subtract these. So let's see, minus 50.75, and I'm being a little lazy and using a calculator here. So 47.95, because we go through and subtract. So if you were going to line these up and do this on paper, you want to make sure that your decimal is lined up because it's going to come straight down. You just subtract straight down here. So I'd have to borrow with these pieces like this. I have 17, and that would give me 9. 10 minus 2. Oh, I borrowed again. Sorry, that should be 9. Should give me 7 and 4. I forgot to borrow again when because I had to borrow to make it 10, then I would borrow again to make that 17. All right, so we have 47.95. All right, couple more of these and we're all done with this section. Okay, so the owners of a recreation area are filling a small pond with water. So here's our small pond. Let W be the total amount of water in the pond. So this is W. And let T be the total number of minutes that water is being added. And I'm not real great at drawing this one, so I always just draw some drops happening here. And we have our recreation person here who's adding the water. I know I'm very good at drawing my recreation people here. And we'll give them some hair. So here they are, they're adding water. And then we're told, suppose that W equals 35T plus 700 gives W as a function T during the next 80 minutes. So we know it's going to be happening for 80 minutes. They're going to be adding water for 80 minutes. So if I think about this equation, W is the amount of water in the pond. T is the number of minutes that they're doing, adding this water. And then I have these other numbers here. I have 35 times T. Well, that sounds like a change. It's being multiplied. So this other number is going to be our starting point. So right now, this guy has 700 liters in it. That's my starting point. And I'm going to add 35 liters per minute, which they told us is T. That's why it's times T. But the owner is adding 35 liters every minute. That's what the 35T looks like. So we've already broken this down, and we've worked with a couple of these problems now. So I'm hoping we get to the point now where we can understand this addition, this number is my starting point. What's being multiplied is what I'm changing by each, every, per, whatever the problem introduces to me. So if I have W equals 35T plus 700, and then they want to ask some questions. It says we're going to identify the domain and the range. And domain is another way of talking about the input. So this is going to be my input. I'm choosing the number of minutes here. So this is my input, and this is going to be my output. The amount of water in the pond is my final amount there. So an input is going to be my domain. Domain is another way of identifying the x coordinates or the x-axis. So if I know that my domain is going to be the amount or the number of minutes, I can go ahead and click that, the number of minutes. And my range, that's your y values or your total values. That's going to be the amount of water in the pond. So again, domain and range, just new words that are thrown out there. I think we've looked at them before. So just kind of reviewed those very quickly. So now we have this drop down and we have to choose which one is the correct one for our input. So if input is the number of minutes water is being added, so right now, before we've started adding anything, this would be the 0 minute mark, and we have 700 liters there, right? So at 0 minutes, before we've started adding water, we have 700 liters. And then they told us it's only going to be going for the next 80 minutes. And I need to know what's going to be my output at 80 minutes. But I can put in time anywhere from 0 to 80. So that's going to be kind of my limit there. I need to pick one that has 0 to 80 so I can see the set of all real numbers between 0 and 80, because that's my time limit. I can either not have started yet, or I can go for 80 minutes. The range has to do with how much water is in there based on that number of minutes. So we already know at the 0 mark, at the starting, we have 0 or 700. Now I need to know how much will I have at 80 minutes, because that'll tell me what the top limit of my range is. Right now I can't have less than 700, but I want to know what I can't have more than. So we're going to go and do this multiplication here. So we're going to go 35 times 80. We get 2,800. Now we had 700. Let me make sure. 35 times 80. I want to make sure there was nothing else in my calculator. Yep, that's exactly how that is. And so we're just going to add these together. So we go plus 700, and we get 3,500. So this is my maximum. So at 80 minutes, I'd have 3,500. So I can start with 700, can't be less than that, and I can't go above 3,500 because at 80 minutes, I'm cutting the water off. I'm stopping. So I can have numbers for my range anywhere from 7 to 3,500. So here it is, that's that second one. And if it was one of these guys down here, it would look the same way, but instead of starting with one of these numbers, it would start with 700, give you a couple, and then go ... 3,500. So this one's kind of close, but it's starting at 80, which that 80 is the number of minutes, not the amount of water in the pond. So we just want to be careful with that. Okay, let's go to our last guy here. All right, so the function g is defined as the following for the domain given. So we have g of x equals 2 minus 3x, so this is our rule. I have to multiply x by -3 and then add 2. And here's our domain. Write the range of g using set notation, then graph g. So with this one, if you've never done set notation or anything, this is where you'd want to come in here and go, what exactly are they asking me to do? So with this one, the domain means the input. This is what they want us to input here. And we have a little output kind of like the calculation. And then here are the coordinates, so they put them together. If x is -2, then g of x is -3 because they had g of x instead of the one that we have. So -2, -3, -1, they got -1 again. 0, and they got 1. So they're doing an input-output, and then they're creating coordinates for this because that's what these are. They're coordinates. We just haven't graphed them yet. So then they go through and they start graphing them. And the range is just all the outputs that you had. And what set notation means, it's in these little kind of fancy brackets. Okay, so now that we've seen that, because that's a little easier, I think, to see than for me to write it and explain it all over here, we're going to go through and we're going to do g of x equals 2 minus 3x. And I'm going to go through and I'm going to plug these numbers in. So the first number they want us to do is -1. And it's going to equal 2 minus 3 times -1. So -3 times -1, do the multiplication first. That gives you a +3 plus 2, which gives us 5. So that is our first output. That's our first range piece here. So we want to make sure we click the little braces, those little fancy brackets. 5 is our first one. And then we're going to have g of, let's see, what's the next one here? We have 0. So 0, I know I keep going back and forth in my colors, equals 2, -3 times 0 is 0. 2 minus 0 is just, not 0, 2. So our next output is going to be 2, comma, then we have g of 2 minus 3 times, so our next one is 1 that they're asking us to put in here. Why didn't it change? 1. So now I have 2, -3 times 1 is -3. 2 minus 3 is -1. So my next output is -1, comma. Now I'm going to have my last piece here, 2 minus 3. And our last input is 2. So I'm going to have 2, -3 times 2 is -6, and 2 minus 6 is -4. So my last one is -4. All right, now I can go through and I can start graphing these. And so we want to remember that when we graph these, we have pieces here. We have coordinates. And I'll put them in coordinates just like they did on the notes here. So I had 5 for my output, 2 for my output, -1, -4, and then my input for this one is -1, 0, 1, and 2. So remember, these are directions when we're looking at a coordinate grid. So what this tells me is if I'm going from the center here, and I like to pretend we're literally walking around a city, and these boxes are buildings or houses. We can't walk through them. We have to stay on the lines. The dotted lines are kind of like our streets. We have to stay on those. So from the center here, I want to know how to get to this point. Well, I'm going to go left 1, and because it's negative, I go left to right first. Then I'm going to go up 5. So I'm going to grab my little pencil tool here. I'm going to go left 1 and up 5, like that. So then I go back to the center, and I do the next one. I'm going to go, oh, not left, 0. I don't move at all. 0 tells me I don't move. So I don't go right or left. I just go up 2. And I put a dot there. For the next one, I'm going to go right 1 because it's positive, and down 1 because it's negative. So I go back to the center and I go right 1, down 1. So for that last one, I'm going to go right 2, down 4 from the center. Right 2, down 4. We can kind of see this is actually turning into a line. Hopefully we can picture that. All right, so then we click check and we are good to go. Yay, that one was definitely a little bit longer one. So that was section 3. I will see you in section 4.